Today we will discuss game theory. That next part, mixed game. We have discussed already in the last video that there will be no saddle point, then it is a mixed game. But we have discussed the dominance rule. Now, if you find the game 2 rows more columns, 2 into 3 means 2 rows, 5 columns, means maximizing player has two strategies, but minimizing player has 5 or 4 or more than 2 strategies. So the game will be 2 by n, or m cross 2 means maximizing player has m strategies, which is obviously more than 2, but minimizing player has only 2 strategies. So these two cases must be converted to 2 rows, 2 columns. So you will be telling that we should apply uh, dominance principle. Yes, it can be applied. Dominance principle is not impossible, but most of the cases we see that dominance principle sometimes fails. There's 2 rows, n columns, or m rows, 2 columns. These two cases, when dominance principle fails, we apply the best method is graphical. So a student defined that 2 rows, 3 columns, or 2 rows, 5 columns, 4 columns. So go to math directly graphical. No requirement. If it is mixed game, that means no saddle point. And when you are finding that m rows, 2 columns, then also you can go directly to graphical, then 2 cross 2. That means ultimately mixed game, ultimate target is 2 rows, 2 columns, 2, 2. But in dominance we have seen after applying dominance principle 2 rows, 2 columns, but in graphical we will be not applying dominance at all. We will apply graphical principle to reduce the matrix to 2 rows, 2 columns. The basic idea is maximizing players strategy and minimizing player strategy. Maximizing player strategy always should be to get the idea of maximum. Remember in saddle point, maximum, that means maximum of minimum, maximum. And minimizing player strategy will be minimax, minimum of maximum. These two words you must remember. For 2 rows, n columns, 2 cross n, we will remember maximum point, because this is A's idea. A is not having any problem. A has no problem. A has 2 rows already. We have to solve the graphical idea with A's point of view. That way, not A's point of view, A will be already 2. So what we will do? Maximum of minimum concept. That I will discuss how to get maximum minimum. If it is m cross 2, m cross 2, m rows, n column, 2 columns, m rows, 2 columns, then you remember this will be minimax concept. So in graph, in the case of graph, you remember graphical method will be based on 2 rows, n columns, maximum concept, and m rows, 2 columns, minimax concept, minimum of maximum. Now how to solve? I am doing 2 problems now. One is for maximum idea of 2 cross something like 3 or 4 matrix through, that is 2 rows and more columns, more than 2 columns, and then I will do more rows and then 2 columns. Now first is 2 rows. Let us take an example of 2 rows, 4 columns. So solve the game. Obviously question will be like this. Solve the game and it is given as A strategy A1, A2. That means 2 rows, and B strategies are B1, B2, B3, B4. B1, B2, B3, B4. Now B1, for B1, look at B1. A1, A2 has these 2 values. For B1 only, I am seeing B1 given as 1, 3. So when we are looking at A has taken either A1 or A2. So B1 has 2 values, 1, 3. Now for B2, B2 is given as 4 minus 2, and then B3 0, 7, and B4 is 3, 1. This is the problem. So please look at the problem that this is the matrix, solve the game. A is maximizing player, B is minimizing player as before, and we are wanting to solve this game. And when you find this game is given, normal ideas cannot be pure game. Cannot be. Why? Because normally this type of problem is so simple, we don't expect it to be a pure game. Let us check if I want to do whether it is pure game or not. That means 1, 4, 0, 3 for A1 and 3 minus 2, 7, 1. We are taking the row minimum for the sake of whether it is really mixed game or not. Minimum is 0 and minimum is minus 2. So what is the maximum value? This is the maximum value. So maximum value of this row wise calculation 0. Now take the maximum. Now we are taking minimax. For that column maximum you take. We are checking the saddle point. This is 3, this is 4, this is 7, this is 3. This is 3 and that is also 3. So 3 is the minimum value. Now you do. This is 0 and this is 3. So there will be no deterministic value. It should be a mixed game. The value of the ultimate value of the game will lie between 0 to 3. This is the lower value and this is the upper value. So lower value of the game will be 0 at the minimum and the maximum value will be 3. So the actual optimum solution of the game will be between 0 to 3. Now how to find? So we will be telling it's a very simple idea. We will apply dominance. No, I am not telling you to do dominance because sometime maybe you will be thinking that if you want you can apply dominance, you can if it is not mentioned. But most of the cases we have seen that question has mentioned use graphical. Use graphical. Therefore, if you are finding that graphical method is clearly mentioned, there is no problem. No question of seeing whether it is mixed or pure game. But it is not mentioned graphical. Just said solve the game. Then obviously we will first check the maximum minimax values are equal or not. In this case, we are not finding any pure that is deterministic concept. We have to find the probabilistic concept, and our target will be to reach 2 rows, 2 columns. Now look at this problem very carefully. No question of row dominance at all. If you want to apply dominance concept. Now whether it is possible to apply the concept of column dominance. Normally we don't have any scope. So we don't need to straight go to graphical because 2 rows, 4 columns. Best is graphical. How to do the graphical, draw the graphical that is diagram. What is the basic idea? A1, A2. We are thinking from A's point of view. Actually it's not A's point of view, but I am telling you to remember that when 2 rows are there, we emphasize A. A1, A2. 2 axes. 2 parallel lines. A1 is first line drawn and the second line drawn is A2. So how to show the diagram, graph A1, A2, 2. Now look, maximum value first A1 has 4, minimum 0 and A2 has maximum 7 in the case of second row and minimum is minus 2. So how will it do? Now this is the A1 line. Maximum value is 4, minimum value is 0. But in case of A2, it is minimum value is minus 2 and maximum value is 7. So we do this way. Let us take the origin. This is the 0, 0 line. I am taking more space on the upper side. Why? I am showing. 0, 0 means 0 is the origin and A2, 0 is the origin. A1, 0 and A2 also 0. Now when it is minus values, it will go below it will be shown below the origin. That means minus 1, minus 2 this side. But A1 has no minus value. Okay, no problem. I have drawn this way because when I am drawing minus 1, this side also I will show minus 1, this side I will show minus 2. Why minus 2? If you look at A2, not B, A2, then you are finding the lowest value is minus 2. That's why I have drawn minus 2. We don't need to draw minus 3, minus 4. Just draw the line. How you are drawing this? No graph paper if you are finding. You draw 2 lines not very far away, more or less reasonable gap. And then you take 1 centimeter like that and reasonable length 1 minus 2 same, minus 1, minus 2. Now going upward, 1, 2, same gap, 3, 4, 5, how many? I am adding 4. So you can stop here up to 4. But A2 requires 7. So let us move up to 7. So A2 requires 7. So why I am drawing 7 in A1? Because both sides will be equally drawn. The graph A1 line and A2 line equally this scale should be shown. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6 and this is 7. So I have drawn A1 line putting these values. No, I'll put, but just made the scale. An A2 line again made the scale, but such a way I have made the scale, I have drawn the scale that I can accommodate all the values given here. Now how to draw? First, for A1 and A2, in the case of B1, means when I am going to draw this graph, look at B1. 1 is B1 A1. B1 A1 means on the line A1, this axis A1, this line is A1. For B1 value it will be 1. So here, and now go to A2. The same strategy of B1, now go to A2. A2 is 3. 1, 2, 3. So what I am finding? B1 strategy require A1 as 1. On the A1 line I have taken the point 1. And B1 same strategy, A2 axis it is 3. Now you join. This is the strategy line for B1. That means B1 will be shown in the graph paper. These two are axis, A1 axis, A2 axis. This line is B1 strategy line. This is the idea of graph. So this idea, what a B1 is requiring, what B is the idea is what? B is loss. B means loss. So we cannot allow any loss above this line. Why? Why we not allow any value above this line? Because this is the strategy line for B. B will not allow anything more than this value. B is wanting to restrict the game value within this line. So it will be lower than this line. Now go to second. B2. Now go to the second. What is B2? B2 on the A1 line will be 4. B2 on the A1 line will be 4. And A2, when B2 and the corresponding is A2, is minus 2. So this is the minus 2. We will join this one. So this is the second B2. So what you are finding? B1 line is this line. On the axis A1 and A2 we have drawn 2 points and joined. What you will remember in the mind, in our mind, back of the mind, we are remembering that B1 will not allow any value of the game above this. And what about B2? B2 now, second strategy of B, will not allow any value above this. So we should take both together in the game. Our point will be this portion. It will not allow anything above this. It will not allow anything above this, and it will not allow this line will not allow anything above this. So this portion is the common portion, but there are more lines because B has more strategies. Take the next line, B3. B3 is 0 and 7. 0 and 7. So B3 will be 0 and 7, somewhere here. I will show the diagram better way because I am drawing without any scale. Something like this. This is the B3 line. So what is B3 line? B3 line will be, you have to draw very properly with scale. I will show the better drawing now after this. This I have checked already. This is the line. So B3 is going through the intersection of B1 and B2. Yes. Sometimes it is not. Sometimes it is not. If it is not, it is not. I think it is drawn properly. There will be small gap. I have drawn that way that it is intersecting. Actually, I was trying to establish that sometime it may go through. No, this case it will not go through the common point. You have to take the scale and draw properly. Properly, if you draw, you will get the line accurately. You take scale, take proper pencils and all, and if you draw, and something like this is coming. So B1 line, this is the line. The target of B1 is, this is the B1 line. The target of B1 is anything of the game should be lower than this line. For the B2 line, it will not allow the value of the game above this line. And now the third strategy will not allow anything above this line. So what is the idea coming? Look at this portion. It is the common shaded region, the lower portion. Now come to the last 3, 1. 3, 1. That means this one. 3 is here. A1 on A1. Fourth strategy. This is first strategy, this is second strategy for B, and this is the third strategy. Our target is to search 2 strategies of B, because we have already got 2 strategies of A. I need 2 rows, 2 columns. So I have to find out B's 2 strategies will be there. Now how to find that in the graph? Let us draw the lines of the strategies. So for the fourth strategy of B, which is 3 and this is 1. 3 and 1. Now you join 3, 1, something like this. So this is coming. So this diagram is actually showing the diagram of A1, A2 correspondingly. This is B1, B2, B3, B4. B1, B2, B3, B4. 4 lines all are B's strategy line. Now what does strategy line indicate? B1 will not allow any value of the game above this line, because B means the loss. B is a losing player. He will not allow to lose more. Then the second, B2. Again, the second strategy will not allow anything above this. So below, we are searching the common shaded region. Look at this. B1 will not allow anything above this. B2 will not allow anything above this. B3 will not allow anything above this, and B4 will not allow anything above this. So what is happening? This is the portion. You have to practice properly. We are shading the lower portion of the lines, and if you draw properly, all the lines showing the lower portion. So what is the common shaded region? Here is the question. This line will not allow anything above this. This is the fourth line. Third line, sorry, this is the third line. B3. B3 will not allow any value to go above this. So B3 will restrict the value of the game within this line. Now B1 will not allow anything above this. So this portion will be restricted. Now B4, it is above. B4 is not inside the shaded region, because B3, B1 and B2 restricted the region, and this region is called lower envelope. You know, there is a word in economics also you have heard. Enveloping portion. That means the covering portion. So ultimately, which is the covering portion? B1, sorry, this is B1. B1 has small portion here. B2 and B4. B3, sorry. So B1, B2, B3. B4 is not ultimately giving any contribution to the common region. Now what I said, maxi mean point for this case. The graphically we have to search maxi mean point. So I have drawn all the lines corresponding to A1, A2. A1 axis, A2 axis, then B1 I have drawn, B2 I have drawn, B3 I have drawn, B4 I have drawn. And shaded the region. After shading the region, what you are finding, which is the common shaded region. If you want, you can draw one thing you can do. You can shade very lightly with your pencil, very lightly, in different orientations. For B1 you can show this side, B2 you can show that side, B3 you can show a little bit of straight, and then B4 the other way. And see which portion of the graph is common shaded region. Common shaded region. In linear programming, yes, LPP. Game theory is a part of LPP also, that we will discuss in the future after learning LPP, linear programming. We have learned a little bit of LPP, I hope that you know, a common shaded region. Here also the common shaded region, what is the concept? Lower portion for B1, B2, B3, B4 will be shaded. And when you have shaded the common, all the portions below the lines, B1, B2, B3, B4, whatever the lines for B, you will be getting a common region. And that common region, maxi-min, this region is a minimum region. It will not allow to go above. Maximum of the minimum portion. We say highest point of lower envelope or common region. I am writing envelope. Envelope is a technical name. For your understanding, you can remember highest point of the lower common shaded region means the line's lower portion which is shaded, that portion's highest point. Now look at the highest point. What is the highest point? That means this portion, highest point is, what are the corner points? Corner point is this one is corner point, this one is corner point of the shaded portion, this one is corner point and this one is corner point. 4 corner points we are finding for the shaded region. First region, second region, all the lines, first line, second line, third line, whatever it is. The common region has 1, 2, 3, 4 corner points. Which is the highest point? This is the highest point. Remember, whenever the highest point is such, it should be intersection of two opposite direction line. Two lines will be always, one will be going up, another will be going down. The line B2 and B1. B2, this is the line B2, this point. This point is the highest point because this and this 4 common corner points we are finding for the common region. It is open shaded region, lower portion of all the lines. And this shaded region, highest point. This is the highest point. And what is that point? Common point, common region, not common point. This region, which is the common region, highest point of the common region, which is the maximum point, I can say, maximum of minimum portion is this. What is that point? This line B1 and this line B2. So B1, B2, yes. So B3, B2, B4 are not ultimately giving any effect in the value of the game. So it is dominated. But this dominance principle is not the idea of dominance principle we have learned in the dominance principle as a algebraic concept. In graphical one, when you are learning the graphical idea, these two are dominated. B4 and B3 will not be taken. So what is the final 2 cross 2 matrix? 2 cross 2 matrix is 1, 4, 3 minus 2. I hope that this is your reduced matrix from 2 cross 4. And 2 rows, 4 columns reduced to 2 rows, 2 columns using the graph. We don't need any more graph. So I think this diagram is hopefully clear to all of you. So we can now proceed to what? 2 rows, 2 columns concept. We don't need anything about B3, B4. And I think you remember what is the probability of A1, that is we denote by P, and the value is 3 minus minus 2. I hope that you remember 2 minus, sorry. Minus 2 minus 3. Minus 2 this side. I told you this by this plus this negative side. So minus 2 minus 3 divided by 1 minus 2 minus 3 plus 4. This is the value. So what is coming? This is coming minus 5 and the lower part is minus 1 plus minus 7. Minus 1 minus, this is 1 minus 2 and the other one is, the result is I think, just check the calculation if it is anything wrong. 1 minus 2 is minus 1 and this is coming to be 7. Minus 7. Minus 1 minus 7. This is minus 8. So 5 by 8. So what is the result? I hope that you remember last time's discussion. 2 rows, 2 columns. This plus this. When you are adding this plus this is minus 1. Then this plus this is minus, this is 7. Automatically minus 1 minus 7 is minus 8. And that value is plus 5. So this is 5 by 8. And probability of A, B1, that is Q. What is that value? That is minus 2 minus 4 and the divided by 7. The value is same. That means minus 6 by 8 which is minus 8 which is 3 by, cancelling with 2, 3 by 4. So I hope that you have understood the concept of game with the idea of the graphical idea of game. But finally, your value of the game is, of course, we remember, this is the final matrix I told you because already I have shown the dominance part. The result is 1 into the numerator, 1 into minus 2, that is minus 2, minus 3 into 4, minus 12, divided by, already you have found, this is minus 1, adding these two, and this is minus 7. So minus 8. So the result is minus 14 by minus 8, and the calculation is giving you minus cancelled 7 by 4. 1 point something, 1.375. So it is the concept. I think you have understood the idea of game, but what is your answer? What will be your answer? Your answer will be A1, B1 you have found. So automatically A2 and B2 are the rest, that one complement of these two. So your answer will be value of the game corresponding to A strategy. What is the A strategies? A strategy is the probability I think we have got. It is before the value was, what was the value? I think we have found that just now a P is found minus 1 minus that one. So it is 5 by 8, then 3 by 8. Why? Because when you are finding A1 as minus 1 minus 7, this is denominator is minus 8, and this is minus 2 minus 3, that is 5. Baki do 0. Because they are dominated article. Here B's case, sorry, this is not 0. B's case it will be 0 because A has 2 rows, 2 columns. A has 2 rows, 2 columns. A1, A2. A1 strategy is this and A2 strategy is this. And what about B? B's probability, we have 3 by 4, then 1 by 4. Because 3 by 4 is that complement of 3 by 4, but 1 minus this, then the other 2 is 0. So your answer is optimum value is 7 by 4 corresponding to A strategies respectively 5 by 8 and 3 by 8, and B strategy will be 3 by 4, 1 by 4 and 0, 0. This is all about 2 rows, 4 columns. With 2 rows, 4 columns. Now we are proceeding to the next type. Now coming to the next type. What is the next? So I hope you have understood when 2 rows, 4 columns or 5 columns, that means 2 cross AM games. Then we have the idea of maximum concept, the lower portion and the higher part. Now come to the next concept, and that is M cross 2 game. M cross 2 game. So more rows and 2 columns. So we will be discussing minimax concept. Now what is the problem? Solve the game using graphical method. Suppose they have said solve using graphical. No scope to apply other things. They have just mentioned it. Using graphical method, you solve the game. And question is like this. A has 3 strategies. A1, A2, A3. And B has 2 strategies. That is 2 minus 3 is 1, minus 2, 5 and 1, 4. So this is the matrix. So here you are finding clearly 3 rows, 2 columns. So what you need to do? 2 rows, 2 columns our target. That means I have to reduce this matrix to 2 rows, 2 columns. Already 2 columns we are having in this case. So you have to find how to reduce A1, A2, A3 to any of the 2. Not to take all the 3 strategies for A. And I will draw. First thing we will draw. And what is the idea of drawing? 2 lines. One line is for B1 and second line is for B2. What was the difference with the last case? That was A1, A2 because we have 2 strategies for A only in the previous problem. In this case we have 2 strategies for B. So B1 is the strategy and B2 is the strategy axis, along the axis. This is the B1 axis, I can say this is B2 axis. Now what do you do? First thing, what is the maximum value of this line? Maximum value is 2 and minimum value minus 2. On the other side, minimum value is minus 3 and maximum is 5. So I have to scale this way. This is origin 0, 0. The scaling will be minus 1, minus 2, minus 3. So all this same scale you use on the right side. B1, B2. Now this side it will be 1, 2, 3 and 4 and 5, because although this B1 line we have maximum 2, but since B2 line will be requiring 5, so let us take both scale on both sides of this B1 and B2 line same manner, but properly you just draw the scale. Gap should be same. In this case, since I am drawing without any scale and all, this scaling is little bit not equal. Should take equal. Properly you should draw. Now what you do? First thing, A1, 2 minus 3. So it will be for the line A1, the strategy line for A1. Now we are not seeing B strategy line. We are now seeing A strategy line. In the previous case, when you have drawn A1, A2 axis and we are drawing the strategies for B. Now it will be other way. B1, B2 already fixed. I have to draw the line for strategies of A. A1 on the axis B1 will be 2. So this is 2. And B2 it is minus 3. So what is the point? 2 to minus 3. This is the A1 line. So A1 line will be the line which is 2 minus 3. A1 B1. This is 2. A1 B1. This is A1 B1. A1 B1 is 2. And A1 B2 is minus 3. A1 B2. Now what is the meaning? What is the idea of A means maximizing player. So A will not allow any profit below this. In the case of B's case, in the previous case, we have seen that we will not allow anything below this because that was the line for B. B is a minimizing player. His strategies should be to restrict the loss. And in this case, A strategies will be to increase profit. So A will want, A's target will be to get more and more profit. So above. We are wanting to get the portion above the line A1. Now take A2. A2 is minus 2. And what is B2's point value? Plus 5. So it is joint. So this is A2 line. So this A2 line is A2 will not allow anything below this. It will be always above because A is maximizing player. So it will want to have more and more profit. It should not be any profit below this line and this line also. So we are getting the common shaded region as this portion, this above, not from below, it will be above. But one more strategy for A is there, that is 1 and 4. 1 and 4. 1 and 4. So we draw 1 and 4. This is A3. So now we have the concept. What is the concept? Mini max. I told you, when it is 2 rows, 4 columns or anything, then it will be maximin. So from the lower portion we took the maximum point. Now it is mini max. So maximum target to get the more profit. So we look at A1's portion, it will be above this line. Above this line. You can draw very light manner before getting the common region. Now A2, A3, this is the line A3, above this portion. You can draw more shading, but we are wanting the common shaded region. Now A2 is this portion. Now you see which is the common shaded region. This portion, this is the common shaded region. If you draw fully, I am not telling that you must draw, I am telling you can draw. But if you practice, you will understand the portion which is the common shaded region. This is the common shaded region. The corner point 1, 2, 3, 4. Normally 4 or 5 like this corner point. So it is mini max. I told you this is mini max concept. That means minimum, that is the lowest point. In the case I told you highest point of lower envelope. Now it is lowest point of higher common region or envelope, we can say. Common region is technically called enveloping portion, covering portion. So which is the lowest point? This point, this point, this point, this point. Again, two lines are oppositely directly. This is downward line, this is upward line. Always. If you take this point, both lines are upward line. This line is upward, this line is upward. Always the best point will be two opposite directions. The line moving in the two opposite directions, the intersection will be arising. So here we are finding that region is, the lower point of the region is this point. And what is the point? This is A1, A3. So our final idea is reduced matrix is A1, A1, A3. So this is removed. Why? Because 2 rows, 2 columns. So our target is fulfilled. What was the target? To reduce the big matrix, that was 3 rows, 2 columns to 2 rows, 2 columns. Now you look, we have reduced the matrix to 2 rows, 2 columns. How we have reduced? Seeing the common shaded region and finding the best point. What is the best point for 2 rows, 3 rows, 2 columns, or 4 rows, 2 columns, or 5 rows, 2 columns? It will be mini max point. maximum area, minimum point, mini max, minimum of the maximum portion, that is the lowest portion of the higher part. And in the previous case it was maximin, that is the highest point of the lower portion. Now we can solve. What is probability of A1? That is P. Very simple. It is 4 minus 1 by 2 plus 4, 6 minus of minus 2. That is 3 by 8. This is the 3 by 8 probability. And this probability of next one, I am just now removing because already you have achieved our target. No more graph is now required. Whenever you have identified those two columns, no graph is required. P, A2, A3 is what? A3, because A2 is removed. A3 means 1 minus 3 by 8, that is 5 by 8. Now what is P, B1, that is Q we say, and the idea is 4 minus minus 3, that is 7 divided by 8. And B2's value will be 1 minus this, 1 by 8. And what is the optimum value of the game? Value of the game is this plus this, 6, this into this, sorry, this into this, 8, minus of minus 3, 8 plus 3 is 11, 8 plus 3, 11, divided by, this one is, I think, 2 plus 4 is 6, 1 minus 3 is minus 2, 6 minus minus 2 is 8, so it is 11 by 8. So our answer will be, what is the final answer? Final answer will be, optimum value of the game is 11 by 8, and your corresponding values of the game we can write A1, A2, A3. A2 is 0, A1 we have found 3 by 8, that is A strategy will be 3 by 8, 0, 5 by 8, because A2 is removed, and B strategy will be corresponding counter strategy for B will be 7 by 8, 1 by 8. So I think you have understood this concept of graphical solution, and the graphical solution needs to reduce the bigger matrix to smaller matrix with the concept of drawing the higher portion, highest point of the lower part, or other way, lowest point of the higher portion, and getting the point, then we we take those two columns and accordingly solve. You please check the method. If any calculation problem is there, you just adjust. And I hope that this video will help you to learn the graphical concept of game theory problems. One more topic will be done later, that is using linear programming, which is a bit complicated concept because we have to learn linear programming at first. That I will do after learning linear programming. For the time being, this is I think almost game theory is completed. Thank you for this topic.